All right, sixth grade, we've gotten some practice at calculating area, perimeter. We're talking about different shapes and how to understand how much space that they're taking up in 2 dimensions. But today we're going to start talking about volume, which you should be a little bit familiar with, but we're going to maybe do some more complex volumes and just try and review kind of what is a volume, what does it describe, and how do we calculate it, and why does that make sense. So name, date, title, and I'm going to show you just a quick little demonstration that you do not have to copy down. These should look familiar. These are our two shapes that we've been calculating areas of a lot recently. That's a triangle and a parallelogram, and we've been using the height and the base to calculate for each. Now what we did is we first derived a formula. We figured out a formula for finding base times height equals the area of a parallelogram, and we based that off the idea that it's really easy to think of a rectangle as having the number of square units equal to its base times its height. For example, the base of 3 units here says that we have 3 units in a row, but then 5 tells us we're going to have 5 rows. So we have 5 units high, that means we're going to have 5 rows of 3 units, and so that's why we multiplied base times height for a rectangle. The new question is, what do we do for volume? Well, we just need to figure out what is the 3-dimensional shape based off of. So we'll just look at the front face when we're finding volume, and then we'll think, okay, if we have 15 units here, 15 square units, what do we start thinking about when we make this a 3D shape? And what we do here is we realize that these 15 squares can also represent 3D cubes. In this case, hopefully it's easy to see that we would still have 15 cubes up front. Now there's going to be an added step in finding volume, and hopefully you're going to see is that if we're finding how many of these cubes are in this whole shape, we need to think there's not only these 15 cubes up front that go along with that area in the front, we need to think there's not only 15 cubes, but there's 3 layers of 15 cubes. So what we're going to do is take this 15 and say we have 1 times 2 times 3 groups of 15 cubes, which would be 45 cubic units, or 45 units cubed. So we have a new unit that we're measuring in, and also we need to realize that what we're doing here is we're multiplying by the depth. So first we're just finding the area up front, and then we're multiplying by how many layers there are. So here are the notes. You might want to listen to me explain them before you pause and copy them down. But the first just says that volume measures space taken up in 3 dimensions. So area was in 2 dimensions, but volume is in 3 dimensions. For that reason, it's measured in cubic units. So we're going to multiply a base, a height, and a depth, or something in that order, something like that. So we'll be multiplying a unit 3 times, and any number multiplied 3 times, or any unit multiplied by 3 times, can be written to the 3rd power, or cubed. And it also makes sense in that picture that we need cubes to fill up a 3-dimensional space. If you're going to fill up a box, you need to fill it with little cubes. Little squares would just fall flat to the bottom, and they wouldn't fill it up. How can we calculate volume? We can calculate it by finding the area of a face, or the front section, and then multiplying by the depth of the object. And again, the idea there is we're multiplying by the number of layers. What's it going to look like? Well, volume for a parallelogram, we're just going to find the face. That's base times height. That's the area. But then we need to multiply by the depth. Same thing for triangle. We'll find 1/2 base times the height. That's the main face. But then we multiply by however many layers there are to that triangle. So let's see what it looks like. This first one says find the volume. And what we have here, hopefully you see, is a parallelogram prism. So we have a parallelogram prism, and I know that the volume of a parallelogram prism is going to be equal to the area of a parallelogram times the depth. So we can say it's equal to area of a parallelogram times the depth, or however many layers there are. And what's the area of a parallelogram? We know that's base times height. So this is just going to be base times height times depth. We're going to find out how much space does this take up just in that front section, and then we'll multiply by the 9 layers going back. So we can see our depth is 9 meters. I'll fill that in. Our base is 12 meters. I can fill that in. And our height is 3 meters. Now again, the commutative property of multiplication says we can multiply these in any order we want. Let's multiply 3 and 9 first. I think that's going to be nice. So 12 meters times 3 times 9 would be times 27. And that's meters squared because we multiplied meters times meters. And that's the area we're finding. Now we can do this, work it out. We can do it mentally, but 10 times 27 would be 270. And then I have two more groups of 27. And 27 times 2, we have to add those two more groups because we need 12 groups total. So two more groups of 27 would be 54. And this should be meters cubed. That was a mistake. So our final answer we're going to get here is going to be 324 meters cubed. And again, it's meters cubed, not just because we multiplied meters times meters squared, but also because we need to use little cubes to fill up this three-dimensional space. Three-dimensional units fill up a three-dimensional space. I want you to notice we didn't use this 6 meters, and again, the reason is because when you're finding the area, that front face of a parallelogram, we use base times height, and we ignore this diagonal side. We just use the base and the height, which are the two measurements that the perpendicular, the right angle touch. So that's the first one. Let's do one more. This one is the volume of a triangular prism, and if it's described like this, sometimes it's a lot better to draw it out. So let's draw it out. It says, find the volume of a triangular prism with a base of 6 feet. So I know I have a base of 6 feet, a height of 9 feet, so it's going to be a little bit longer than the 6 feet, a height of 9 feet, and other sides of 12 and 15. So I'm going to redraw this because I know one of the sides needs to be longer than the other. And I might want to make this a little bit bigger in general. So we got 6 feet. If that's 6 feet, then our one side is 12 feet. It should be longer, or it should be double the length. And that looks about double the length. So that'd be 12 feet. That would mean that would have to be our 15 feet. And then our height is 9 feet. And the height is always perpendicular to whatever they said the base was. They said the base was 6 feet in this case. So our height is 9 feet. I hope you're drawing this with me. And then the depth is 4 feet, which means it's going to go back 4 feet. So that's the depth. So how are we going to find this volume? Well, I know that the volume of a triangular prism is going to be equal to the area of the triangle, and then we need to multiply by the depth. So it's going to be area of a triangle. We're just finding that first front face, and then we're going to say how many layers of that triangle are we going to have? How many layers of that area or that volume, just 1 cube deep? So area of a triangle is 1/2 the base times the height. They told us base is 6 feet. Height was 9 feet. And then we also need to multiply by depth, and that's 4 feet. If I was going to multiply this out, I might say that 6 times 9 is 54, and I can, again, multiply in any order I want as long as we're only multiplying. We still need to multiply by 1/2 times 4. I can do that real quickly as well. That's 2. 54 times 2 is going to be 108, and it's going to be feet cubed. Again, because it's a three-dimensional space, so we need to fill it up with cubes. So 1/2 the base times the height shows us the area of this front face, but then we need to multiply by the depth because we're going to have multiple layers of the cubes that are made when we extend this area backwards, or extend that face with a depth. So let me just check my work. We got 1/2 base times the height times the depth. 6 times 9 is 54, 1/2. Okay, this looks great. So I'm going to leave you with some practice problems to do on your own. The first says a rectangular prism has a base of 9 feet and a height of 2.5 or 2 5/10 or 2.5 feet. Its depth is 10 feet. That should be a period. What is its volume? And then finally, I'm asking you to find the volume of this triangular prism. So again, first I would draw this rectangular prism, find the front face, and again, we're just multiplying by the depth. That's the only added step, and you'll find how many cubes or cubic units will take to fill it. So best of luck. I'll see you tomorrow.